Welcome back. Today's goal of this lecture. Today I will see some examples of calculus of variation. I have defined what is the calculus of variation, how we have to solve any extremal of calculus of variation, and today I will discuss more example because I have told you actually calculus of variations very important for higher study and also for all competitive exam. First example, find the extremal of Iyx equal to integration x1 to x2 1 square root of 1 plus y dash whole square dx. And here the subject to the condition yx1 equal to y1 and yx2 equal to y2. Here f of x comma y dash equal to integration x1 to x2 square root of 1 plus y dash whole square dx. Notice here the function is independent of y. So the Euler equation to find extremal of the calculus of variation is, we all of us know, since del f del y is equal to 0, so del f del y equal to 0, so the Euler equation is minus ddx of del f del y dash equal to 0, and del f del y dash means y dash over 1 plus y square root of y dash whole square equal to 0. That imply obviously dd y dash over 1 plus y dash whole square equal to 0. Just integrate both sides, then this would be y dash over square root of 1 plus y dash whole square equal to c. Y dash equal to c times 1 plus square root of y dash whole square, and if we square both sides, then that implies y dash whole square equal to c square times 1 plus y dash whole square. That implies 1 minus c square times y dash whole square equal to c square. That implies y dash whole square equal to c square over 1 minus c square. Consider this constant as a k square. Then that implies y dash equal to k, and that implies y equal to kx plus c2. And obviously this is be the equation of line equation. So this is the shortcut trick when you will see the extremal. If the x in the extremal y is absent, then the equation always would be linear equation. This is the shortcut trick. When y is absent in the extremal, then this equation would be actually equation of linear equation. I hope my all viewers have understood this type of question easily. Okay? Well, next equation is Iyx equal to integration a to b y square plus y dash whole square minus 2y sin x dx has a following extremal with c1 and c2 arbitrary constant. Then here the question, which of the following be the extremal of this functional? Option 1, c1 e to the power 2x plus c2 e to the power minus 2x plus half sin x. Option 2, y equal to c1 e to the power x plus c2 e to the power minus x plus half sin x. Option 3, y equal to c1 e to the power x plus c2 e to the power minus x minus half sin x. And option 4, y equal to c1 e to the power 2x plus c2 e to the power minus 2x plus half cos x. Which of the following be the extremal of these functionals? Here we have to find extremal of this functional. Functional is y square plus y dash whole square minus 2y sin x. del f del y minus d dx of del f del y dash equal to 0. And del f del y means obviously 2y minus 2 sin x minus d dx of del f del y dash means 2y dash equal to 0. That imply 2y minus 2 sin x minus 2y double dash equal to 0. That imply y double dash minus y equal to 2 sin x minus 2 sin x here not minus 2, just common all 2. Then this is the m square minus 1 type equation, m equal to plus minus 1. So yx equal to particular equation is c1 e to the power x plus c2 e to the power minus x. This is the complementary solution. Yx equal to c1 e to the power x plus c2 e to the power minus x. Then the particular solution would be, particular equation is 1 over t square minus 1 minus sin x, and this value would be minus 1 minus 1 minus sin x, and this value would be sin x over 2. So the equation yx equal to c1 e to the power x plus c2 e to the power minus x plus sin x over 2. This is the extremal of this our given functional. That means here the option 2 is a right option. Y equal to c1 e to the power x plus c2 e to the power minus x plus half sin x be the extremal of this functional. I hope my all viewers have understood. Okay? Oh well. Now I will see one interesting question which had come CSIR net December 2016 exam. The question is jy equal to integration 1 to 2 y dash whole square plus 2y y dash plus y square dx with the condition y1 equal to 1 and y2 is the arbitrary any number. Then the extremal is option 1 e to the power x minus 2 1, option 2 e to the power x plus 1, option 3 e to the power 1 minus x, and option 4 e to the power minus x minus 1. Which of the following be the extremal of this functional? Here y2 is arbitrary. For this, here the functional is y dash whole square plus 2y y dash plus y square. Then the Euler equation del f del y minus d dx of del f del y dash equal to 0. That imply 2y dash del f del y means 2y dash plus 2y minus d dx of del f del y dash means 2y dash plus 2y equal to 0. That imply 2y dash plus 2y minus 2y double dash minus 2y dash equal to 0. Just cancel this part, then that imply y double dash minus y equal to 0. This imply the auxiliary equation is m square minus 1 equal to 0, so that imply m equal to plus minus 1. So the equation would be yx equal to c1 e to the power x plus c2 e to the power minus x. Here the given y1 equal to 1, therefore this is 1 equal to c1 e plus c2 e inverse. That imply this part, and also given y2 is arbitrary. For this condition, since y2 is arbitrary, so consider y2 equal to arbitrary number k. And here the method, when given arbitrary numbers, then this would be such type del f del y dash at the point, the upper part of the integral at the point x equal to 2 would be 0. And del f del y dash means, obviously in this functional del f del y dash means 2y dash plus 2y equal to 0. That imply here y, and at the point x equal to 2, here y dash plus y equal to 0 means, y dash means c1 e to the power x minus c2 e to the power minus x plus y means c1 e to the power x plus c2 e to the power minus x. Just cancel this part, then this would be 2 c1 e to the power x equal to 0. And del f del y dash at the point x equal to 2 means c1 is square equal to 0. And obviously square not equal to 0, that implies c1 equal to 0. So since in the given solution I have got c1 equal to 0, so the solution would be yx equal to c2 e to the power minus x. Now we have to find the value of c2, and here I have got c1e plus c2 e to the power minus 1 equal to 1. Since c1 equal to 0, that imply c2 e to the power minus 1 equal to 1. From this expression, that implies c2 equal to e. Now put the value of c2, then this would be e to the power plus 1 minus x. Therefore option 3 is the right option. But notice here given shortcut trick of this functional, here given y1 equal to 1. If we put the value of 1, then I will not get y1 equal to 1. Only I will get y1 equal to 1 for this solution. So this is the shortcut trick. Since here given y1 equal to 1, so by this method we can tell only this is the correct option, because this part is actually for competitive exam, and for competitive exam we have to solve any question very quickly, so you can use this shortcut trick also. Okay? Oh well.